Okay, the second one on sample proportion, and we're looking a bit more at what we described in the last video as the sampling distribution. We're going to focus on a small population in this video just to keep it easy, and we're going to examine it through this exemplar here. And a bag contains 6 blue and 4 red balls. If we take a random sample of size 4, so already we've got a sample, n equals 4. What is the probability that there is one blue ball in the sample? Alright, now let's clarify things a bit here. There is a population, and now there is also a sample of the population. So make sure we understand what this question is asking. So in the population we've got 10. Okay. And yeah, this is very easy, right? This is, you would probably just do the whole census, wouldn't you? But you know, stay with me here. This is concept time. We've got a sample size of 4. Now we would know that the population proportion, the population of that there is, if a blue ball was chosen on any given trial, in other words, the population proportion, it's 6 out of 10, or 0.6. Population probability of selecting one blue ball is 0.6. But what we are being asked to find is the sample proportion. Okay, and it's a sample of size 4. Now there's multiple ways of this happening, so we need to, the most efficient way to deal with this is to go back to selections, okay, which is NCR. Alright, hopefully you remember that, NCR, or also written like this. What we're going to do, and we saw this with the Bernoulli stuff, because our variable is called X, because it's a Bernoulli trial, we're going to call ours NCX. It's just the name. Okay, so that would be written as that, and the formula for combinations or selections, I should say, in this case is n factorial over x factorial times n minus x factorial. If you've forgotten that, go back to one of my earlier videos on this. So what we want to find is a certain probability, and out of a sample size of 4, what is the probability that there is one blue ball in the sample? So what we want to find is the probability of the variable p, the sample proportion variable. Now that's lowercase, remember from the previous video. This basically what we're finding is this. And in this case, this specific case, we are finding this probability here. Uppercase P hat equals 1/4. So what's the probability that the sample proportion is 1/4? And remember, the sample proportion is a random variable. To find the probability, we need to do a little bit of thinking. So we need, this is just a thinking step, so I'll put it in orange. It's supposed to be a line, vinculum line, in fact, fail. So what we want to find on the bottom is the number of ways of choosing or selecting 4 balls from 10 on the bottom. On the top we have 2 things. I'm going to put and there. We have the number of ways for the reds, so ways of choosing 3 red from 4, and the number for the blues, number of ways of choosing 1 blue from 6 available blues. So it's a number of ways of choosing this and that over the total number of selections possible in this arrangement of 10. Okay, so the reds and the required reds and the required blues over the total number. And that's why NCR is more efficient than just doing it with, say, a tree diagram or something like that. So here we go. On the denominator, the number of ways of choosing 4 from 10 is 10C4. Whether you use calculator or more by hand method, we can come up with that answer quite easily. The number of ways of choosing 3 from 4 is 4C3. And is the multiplication principle. And 1 from 6 with the blues. Okay, and if we do the math, we get 4 out of 35. 4/35 as an exact value, or you could approximate it with a decimal. We could go ahead and calculate the other possibilities too for the number of blue balls if we're just focusing on blue. 0, 1, 2, 3, 4. Okay, and we've already done 1 actually. So 1 was this one here we did. Okay. So the sample proportion equal a quarter. We got ours just reduced down to 4/35, that's all. But you can see using the same method with combinatorics to help us with the number of ways we get those values there. And that's the distribution, the sampling distribution, okay, for that random variable sample proportion p hat. More succinctly, it can be summarized like that in that table. So you can see its behavior. Again, this is blue balls based on a sample of 4. There'd be different values if we change those parameters. As a variation of that question, if we needed to find the probability that the sample, from the sample of n equals 4 again, that the proportion was above a quarter, that the sample proportion was above the quarter, we would do the following. We would add the probabilities of this, this, and this together. So it's that case, or that case, or that case, and we'd add those together, and as you can see, it'd be 185 over 210, which you could reduce down. So we can use some of our old probability analyses from our more basic probabilities from earlier work to do variations on the above.